Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray and in this class we will be doing transformation of graphs. So let's get started. Now transformations of graphs helps us to make the graphs of related functions from the graphs of functions we already know. So let's start. First one, y is equal to f of x to y is equal to f of x plus k. First transformation. What we are doing here is we are transforming y is equal to f of x to this y is equal to f of x plus k. That means we are adding a constant k to the whole function. This is the transformation, and the transformation that we do for this is we shift the graph vertically upwards by k units if k is positive, and downwards by k units if k is negative. Why is that? Is because if I add a constant value to the whole function, the value of y is increased by k units or decreased by k units depending upon the sign of k. So for example, I will be taking the graph of sin x in every transformation so that we are able to understand very well what transformations are doing to the graph. Suppose this is the graph of y is equal to sin x. Now if I want to make the graph of y is equal to sin x plus 1, the graph will be like this. It will be shifted by 1 unit upwards vertically. This will be the graph of y is equal to sin x plus 1. This is 2, this is 1. This point will be 2 here, and this is 0. Now if I want to make the graph of y is equal to sin x minus 1, I will start from here, from minus 1, and it will be going like this down, and it will be ending here. This will be the graph of y is equal to sin x minus 1. So we see that we are basically just shifting the graph 1 units or upwards or downwards depending on the sign of the constant. The second transformation is y is equal to f of x to y is equal to f of x plus k. So this time the difference is very visible. What we are doing is we are adding the constant k to the variable. So now in this, everywhere the x, the variable x, will be replaced by x plus k in the function. The transformation we do here is we shift the graph of y is equal to f of x horizontally by k units towards right if k is negative, and towards left if k is positive. So make sure you are not confused here. If k is negative, we will shift it towards right, and if k is positive, then we will shift it towards left. Why that is because if k is positive, we need a smaller value of x to get the same value of y that we get in this function, and if k is negative, then we will need a bigger value of x to get the same value of y that we would have gotten here. So let's take the example of sin x graph. This is the graph of y is equal to sin x from 0 to 2 pi. Now if I want to make the graph of y is equal to sin x plus 1, or rather than x plus 1, sin x minus pi by 4. If I want to make the graph of sin x minus pi by 4, then that graph will be shifted by pi by 4 units towards the right, and like this it will be made. This will be the graph of y is equal to sin x minus pi by 4. Now if I want to make the graph of sin x plus pi by 4, we will shift the graph by pi by 4 units towards left, and we will get the graph like this. This will be the graph of y is equal to sin x plus pi by 4. Right? Let's look at the third transformation. Okay, so the shifting is also known as translation. That means that we are shifting it. Another word for that. Third transformation, y is equal to f of x to y is equal to k into f of x. Now the transformation is we stretch the graph by k times, we stretch the graph k times vertically if k is greater than 1, and we shrink the graph one by k times. We can say we either shrink or we compress the graph 1 by k times if k is greater than 0 and less than 1. Now why this is because if I am multiplying a value more than 1 to the whole function, the value of y is increased k times. That's why we stretch the graph k times if k is greater than 1. And if the a value between 0 and 1 is multiplied to the whole function, the value is decreased 1 by k times. That's why we shrink the graph in that case. For example, this is the graph of y is equal to sin x from 0 to 2 pi. If I want to make the graph of y is equal to 2 sin x, we will stretch the graph vertically 2 times. This will be the graph of y is equal to 2 sin x. Now if I want to make the graph of y is equal to sin x upon 2, then we will shrink the graph 2 times because we are multiplying the function by 1 by 2. So we will shrink the graph 2 times, and this will be the graph of y is equal to sin x upon 2. This will be 1 by 2, and the minimum value will be minus 1 by 2. Next transformation. The fourth transformation is y is equal to f of x to y is equal to f of k into x. So this time we are multiplying the variable, constant k to the variable. That means Wherever x is appearing in the function, it is replaced by kx. For this, the transformation is we shrink the graph horizontally 1 by k times if k times if k is greater than 1, and we stretch the graph 1 by k times if k is greater than 0 and less than 1. Why is this? Is because if I am multiplying k, which is greater than 1, to the variable, I will need a smaller value of x to get the same value of y. That's why we will shrink the graph horizontally in that case. And if I am multiplying by a value between 0 and 1, we will expand the graph horizontally 1 by k times, because we need a bigger value this time to get the same value of y. Let's see with the example of sin x. I'm sorry, I need a smaller graph, smaller space. So I'll take sin x like this time. This is the graph of y is equal to sin x. Now, if I want to make the graph of y is equal to sin 2x, then I will shrink the graph 2 times horizontally. So the graph will be like this. This is pi by 2. This will be the graph. I am shrinking it horizontally. I am compressing it from both sides. So this will be the graph of y is equal to sin 2x. If I want to make the graph of sin x by 2, the graph will be stretched 2 times. So the graph will be like this. I'm sorry. Yeah. It will go up till 2 pi. This will be the graph of y is equal to sin x by 2. So this time we are stretching the graph horizontally. The fifth transformation is y is equal to f of x to y is equal to f of minus x. In this case, we reflect the graph of f of x with respect to the y-axis. This is quite easy to understand. Think about it. The value that, suppose there was a function here, the value that we were getting for 2 here, when x was 2, the value that we were getting would be coming now at minus 2, because minus of minus 2 will mean that this is 2 and we will get the same value. So what this means is the graph that we were getting, say this was the graph of f of x, now it will be reflected with respect to the y-axis. The value that we were getting at 2, we will now get it at minus 2. The value that we were getting at 5, we will now get it at minus 5. So the graph will be reflected with respect to y-axis, and this will be the graph of y is equal to f of minus x. This is the fifth transformation. Let's go to the sixth transformation. Y is equal to f of x to y is equal to minus of f of x. Again, you should be able to think what will be the transformation here. The value that we were getting here will now be coming with a negative sign for this graph. So the transformation is we reflect the graph with respect to the x-axis. So if this was the graph of y is equal to f of x, then this will be the graph of y is equal to minus f of x, a reflection with respect to the x-axis. One last transformation, which is the seventh transformation, is y is equal to f of x to y is equal to f inverse x. The transformation is we reflect the graph of f of x with respect to the line y is equal to x. We have all why we do this is because the roles of x and y are interchanged in inverse functions. That's why the graph will be reflected with respect to y is equal to x. If this is the graph of y is equal to f of x and this is the line y is equal to x, it will pass through the origin. Then the graph of y is equal to f inverse x will be this one. It will be a reflection with respect to this line. So these are all the transformations that we have looked at in this video. I hope you liked the video. If you did, don't forget to hit the like button and subscribe to our channel for more great videos like these.